Bismillahirrahmanirrahim. Today I will solve a randomized complete block design problem from Design and Analysis of Experiments by Montgomery. So let's start the problem. Three different washing solutions as shown in the column are being compared to study their effectiveness in retarding bacteria growth, that is our response variable, in a 5-gallon milk container. The analysis is done in a laboratory where only 3 trials are possible. So you can see it here, only 3 trials per day. Because the days could represent a potential source of variability because of different temperature, humidity, like these variables, the experimenter decides to use a randomized complete block design to log the effect of the days. So observations are collected for the 4 days, and these 4 days are the 4 blocks, and we have to block their effect. I will analyze the problem in the Minitab. So first of all, I will write the name of the variable and then I write the name of my response. I strongly recommend you people to always write the columns first. So we have, for the column, first entry in the column is 1 for which we have 4 entries in the row. So first of all, you will have to write 1 for the 4 times, then 2 again for the 4 times, and then 3 for the 4 times. So we have done with the entries. Then we have 4 days. So write 1, 2, 3, 4 for the solution number 1. Then copy and paste it for solution number 2. Again copy and paste for solution number 3. Then write the response variable. So we have to enter again in the form of the row. So 13, 22, 18. Then 39, 16, 24, 9, 16, 24, then 17, 44, 17, 44, then 5, 4, 1, 22, 5, 4, 1, and 22. We have done with the data completion. After that, go to stat, then go to ANOVA, GLM or general linear model, fit general linear model, select your response variable, bacteria growth. In the factor, select solution and days. Go to graphs. Here select 4 in 1. Click OK. Then click on result. Here click on expanded tables. Then click OK and then OK. After that, wait for the results. Here in the result, you can see we have 2 factor. Both of them are fixed. Solution is taken at 3 levels, 1, 2, 3, and days at 4, 1, 2, 3, 4. Come down towards the residual analysis, because first of all we have to analyze. So although we have a little data, only 12 observations, so we say that almost the data is found to be normally distributed. There is some issue, but however, if we have the observation greater than 30, then we will be better able to analyze the data normality. Secondly, in our residual versus fitted value plots, so these dots are showing the residual values. Those dots that are above this central dashed line, they are positive residuals, and those below this line are negative residuals. So we can see that approximately the number of points below this dashed line are equal to number of residual above this line. So number of negative and positive residuals are equal. It means that our variation in the data is assumed to be equal, or the assumption of the homogeneity of the variance for the ANOVA has been satisfied. Now the loss plot of the residual versus observation order. We can see there are no regular cyclic pattern, there are no trends, there are no 5 points that are continuously above and below this central dashed line, or there are no specific upward trend for the 6 or 7 points or downward trend for the 6 or 7 points. So it means that there is no problem of the multicollinearity in the data, and data is found to be independently distributed. Click OK. So since the assumptions have been satisfied, now we go towards the model summary and the ANOVA results. So for the model summary, it depicts that 94.90% variation in the response variable, that is bacteria growth, has been explained by solution and the days. R square is 97.22. That's a very good value. There's a very minute difference in between both of them. In some paper we use R square, or mostly we use the R square adjusted. Now we talk about the ANOVA table. So ANOVA table depicts us that the p-value associated with both of the parameter, that are solution and the days, the p-value is too small, less than 0.05. The 0.05 is our significance level, or you can say it is our cutoff value. Since both of the values are too small, then both of the parameters are found to be significant, or you can say there is a significant blocking effect of the days on the response variable. And we have separated a huge effect of the days from our results. You can say 1106 is the sum of square, around 59.44% blocking effect of the days were there. Now, since we have to check that which of the solution has the greatest effect of the retarding on the bacteria. So we will have to perform the optimization of the data, for which we will go to stat, ANOVA, GLM, and then we will go towards the response optimizer. Or before going towards, you can see the factorial plots. In the factorial plot, select the bacteria growth as response, and these are to my variable. Click OK. We will get the plot, and from the plot we can clearly see that our solution number 3, it has the minimum of the bacteria growth, so it is found to be the best one. Further, the day number 1 has the least bacteria growth, so it is found to be very good. Day 3 is also seem to be good. However, if you want to optimize it, click on stat, then ANOVA, then general linear model, response optimize, and we say that we want to minimize the bacteria growth. So the goal is to minimize, then click OK. So we will get our optimization result. So here we got that solution number 3 and day number 1 is the best one. Here the fitted value was 0.583 and the composite desirability was 1 of 100. Here you can see the multi-response prediction is solution 3, days and 1. You can also see it graphically that our optimal value is found to be 3 and 1. So it from the general linear model results. So here you can see solution number 1 has a positive effect on the bacteria, 2 also has a positive effect. However, solution number 3 has a very high negative effect on the bacteria. So that's why we have selected. Similarly, from the day 1, 2, 3, 4, the day number 1 has the highest negative effect on the bacteria growth. So it's the optimal one. So that's all for today. Have a good day. If you have any question, please contact me via WhatsApp or via email. Have a good day. Bye.